question 4.3D, we have a hockey puck, and it's moving across a frozen pond, frozen lake, and it already has initial speed. Now, my code is just going to make it 7, and we all have a final velocity of 5, and it does this in, I'm sorry, not 3 seconds, it does this in 7 seconds. The only thing we know for the forces is that there's the force of friction slowing it down, so it's, that is the net force. So F net x is equal to the force of friction. It doesn't really help us much. It's just kind of like a redundant statement. So we have an object that's moving to the right, but is being accelerating to the left, which means it's slowing down. So the first question wants to know what's the net acceleration. So we have, we have our force diagram, we have our motion diagram, we have our force equation. It's not that helpful. Now for the motion equation. Now, for the motion equation, we can figure out A net, by solving for step 2. So A net x, sorry about that scribble there. We have Vix, Vfx, t. So we can use Vfx equals Vix plus A net x times t. So 5 is equal to 7 plus A net x times 7. So we have 5 subtracted by 7, divide that by 7. I'm going to store that as alpha A. So that's going to be alpha A. Now for part B. For part B it says what's the distance? So we solve for dx. We have Vix, Vfx, t, now Ax. Step 3. Why don't we use d is equal to Vfx plus Vix divided by 2 multiplied by t, or we can use d is equal to Vit plus 1/2 at squared. Step 4, dx is going to be equal to 5 plus 7 divided by 2 multiplied by 7. So we get 5 divided by plus 7. Divide that by 2. Multiply that by 7. So dx is 42. All right, now for the last part. Oh, sorry, I made a mistake there. This was the answer for part A. This is the answer for part C. So I skipped a spot. So now let's go back to part B. For part B, it says, what is the average value of the coefficient of kinetic friction? So we just need to solve for mu. So the force of friction is equal to mu times the normal force. Now, we're not given the mass of the hockey puck or its weight, so it's tough to leave it in this format. So the force of friction is the net force. We kind of talked about that. So I'm just going to make this ma net x is equal to mu times m times 9.8, because the force of friction is normal force is equal and opposite to gravity. Just instead of negative 9.8, we'll make it positive 9.8. Now these two masses cancel out conveniently. This is actually alpha A, so it's going to be alpha mu is going to be equal to alpha A divided by 9.8. So mu comes out to be alpha A divided by 9.8. That's my coefficient of friction. And it'll be positive because the coefficient is an absolute value. So actually, if we look back at our equation on a reference table, that's an absolute value. So you end up getting an answer that's going to be 0.0 0 to 9. You make it positive because this is a scalar equation. It only gives you positive answers.